In number 6, we are required to differentiate this function, and we shall do that by differentiating it term by term. But before we do that, let's rewrite it. So basically, for part A, we have f of x will be equal to arc sine x plus 2 multiplied by 1 minus x squared to power half. So that implies that the derivative of this function will be, now we know that the derivative of arc sine x is the square root of 1 minus x squared. And then the derivative of this, we can apply chain rule because we have a function inside another function. So let's start with outside. So we'll have 2 multiplied by a half multiplied by 1 minus x squared to power negative a half. And that is achieved by bringing a half to the left and then reducing the power by 1 to end up with that. And then the derivative of inside will be negative 2x. Okay. So if we simplify this expression, we'll have 1 over square root of 1 minus x squared plus, now this is the same as that's a negative 2x, or minus 2x multiplied by 1 minus x squared to power negative a half. And that will be the required derivative of that function. Now for part B, we are required to find the coordinates, which means the x and y coordinates of the point on the graph of y is equals to f of x, where the gradient of the tangent to the curve is 0. So that basically means the point where f dash x is equals to 0. So I'll just write it down below here. The gradient of the tangent is 0. Gradient of the tangent is 0, where the derivative of that function is equals to 0. Okay, so that implies that we have to equate our gradient function to 0, and our gradient function is 1 over square root of 1 minus x squared minus, and this can be written as 2x over square root of 1 minus x squared. Yeah, because you bring, using laws of indices, you bring this below, and you'll have 2 minus 2x over 1 minus x squared to power half, which is some square root. And this should be equal to 0, which implies that, now because they have the same denominators, we can write this as 1 minus 2x over square root of 1 minus x squared being equal to 0, which implies that, now if you divide this, if you multiply this by 0, it'll just be 0. So you have 1 minus 2x being equal to 0. And that means that x will be equal to a half. So it means that at that point where the gradient of the tangent is 0, x equals to a half. But what is required in this question is the coordinates of that point, which means we have to find the corresponding y coordinate at x equals to a half. So when x is equals to a half, the value of the function at that point, so you have to plug that in the original function, so that will be equal to arc sine a half plus 2 multiplied by the square root of 1 minus a half squared. Yeah. Now, what does arcsine a half mean? Arcsine a half means we need to find an angle whose sine ratio is a half. So from the special triangles, we know that if you have 2, 2, 1, 1, root 3, this angle here is 60 degrees, which is pi over 3, and that is 30 degrees, pi over 6. And we can see that sine pi over 6 is a half. So arcsine a half is actually pi over 6. So that will be equal to pi over 6 plus 2 multiplied by the square root of 1 minus a quarter, which will be equal to pi over 6 plus 2 multiplied by square root of 3 over 4. And this is same as pi over 6 um, plus 2 root 3 over 2. So, and this simply can simplify to just pi over 6 plus root 3. So anyway, at x is equals to a half, we have seen that y is equal to pi over 6 root 3. So the coordinates of the points where the gradient of the tangent is 0 are a half pi over 6 plus root 3. So the coordinates um, are, we have a half and then pi over 6 plus root 3, and that will be your required solution.